Okay, so in this lesson I want to look at establishing some important laws of probability. Specifically, I want to establish the rule for conditional probability and then the rule for multiplication, the multiplication rule for probability. So I have a contingency table here. I have this thing down here. This says the probability of A given B. So we've got two events, A and B. What's the probability of event A occurring given that event B has already occurred? That's what that means. Another way to say that is, if B has occurred, then what is the probability of A then occurring? Okay, so let me just finish out my contingency table. I'm hoping we've done enough on this that I can just, add 10 and 40. It's, pretty much where all the numbers are coming from, 10 and 20, 30, 40 and 30, 70, and a total there of 100. So what we have here is events A, there's 30 total possible outcomes, 30 ways event A can occur, there's 70 ways event A complement can occur, there are 50 ways that event B can occur, and 50 ways that event B complement may occur. And I want to find the probability of A occurring given that B has occurred already. In other words, I'm trying to find the probability of something being in row A given that it has to be in column B. Row A represents all the things in event A, all the different outcomes. Row B represents all the different outcomes in event B, or I should say column B. So I'm trying to find the probability of A given B. So one thing I'm going to do is I'm going to just kind of discount all the things I'm not looking at first. So it's telling me here that I'm given that I'm dealing with B. So I'm given that I'm dealing with column B. So essentially what I'm doing is I am ignoring everything else. So I'm only dealing with that column. Again, if you remember your basic definition for probability of any event, it's the number of ways that event may occur divided by the total number of possible outcomes. If I'm dealing with column B, the total number of outcomes is 50. What is the probability of something being in row A given that it's in column B? Well, the only things in column B that are in row A are these 10 outcomes in here. So it's 1 over 5. Of course, I could write that as 0.2 or 20%. All of those are acceptable answers. That's the probability of A given B. What if I turn it around? What if I said the probability of B given A? Notice that's a vertical line in the middle. It's not at a slant. Slanted line means something else. So what's the probability of B given A? What's the probability of event B occurring given that event A has occurred? Or another way to say that, if event A has occurred, then what is the probability of event B occurring? Like that. So we're given that we have to be dealing with row A, so ultimately here I can kind of discount everything that isn't in row A. I'm trying to find the probability of something being in row B, in column B, given that it has to be in row A. So, well, given that we're dealing with row A, and we know on the bottom is the total number of possible outcomes. Total number of possible outcomes in row A is 30. What's the probability of something being in column B, given that it's in row A? Well, there's only 10 things in there in column B that are in row A, so that will be 1 in 3. And this is called conditional probability. There's a condition. You're given something that has to happen. Here I'm saying I'm given it has to be in column B. Here they're saying you're given it has to be in row A. So you've got a condition. Okay? So, to formalize some kind of rule for that, what we have is, in here we'll have the number of outcomes that are in A intersection B. Down here we'll have the total number of outcomes that are in event B. And over here we'll have the total number of outcomes that are in event A. So if I want to look at the probability of A given B, well, the probability of A given B, I'm given that it has to be in column B. What can I do? I can just ignore everything else, blank out the rest. So given that it has to be in column B, well, we're going to get on the bottom the total number of possible outcomes will be the number of outcomes in event B. Because we're given it has to be in there. What's the probability of it being in A? Well, the probability of being in A will be the number of elements in this cell here that are in A, in row A. And that cell is called A intersection B. Now, probability is just an extension of counting. So the number of outcomes in A intersection B divided by the number of outcomes in B is exactly the same as saying the probability of A intersection B divided by the probability of B. And, logically just flipping it around the other way, the probability of B given A will be the probability of B given A, ignore everything that's not in A. Again, on the bottom, given that it's in A, we're talking about the number of things in A. And the probability that it's in B, well, we're looking for the number of ways this event may occur will be whatever number is in there. And that's the number of elements in A intersection B. So, again, it's the probability of A intersection B on the top. Notice the top is the same in both. A given B and B given A, top of the line is the same. What changes is the bottom. Here we'll have divided by the probability of A. So the thing on the bottom here is always the probability of whatever that is, the condition on the question. Okay, and that's the thing to remember. So remember, learn this by heart. You have to remember this formula. The probability of B given A is equal to the probability of A intersection B, or B intersection A. It doesn't really matter how you write that around. But what does matter is that the thing on the bottom is that, the second one, divided by the probability of A. And you've got to learn that by heart. Notice that the connection, the big one to get right is that. That's where people go wrong. Okay, so that's conditional probability, and you've got to remember that. That's an important rule. That's my conditional probability rule. Let's look at that in action. Suppose a number is selected, there's a typo in there, a number is selected randomly from the digits 1 to 9. Find the probability that the number is prime given that it's odd. And then the second part says find the probability that the number is odd given that it is prime. Okay, so a number is selected randomly from the digits 1 to 9. Find the probability that the number is prime given that it is odd. So find the probability that the number is prime given that it is odd. That's the way we would write that. Again, let me just write down these digits 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So find the probability that it's prime given that it's odd. Well, we know the probability that it's prime given that it's odd will be the probability that it's prime and odd divided by the probability that it's odd. So prime and odd. What numbers in my selection here are prime as odd? 2 is prime, but it's not odd. 3, 5, and 7 are all prime and odd. And again, I could write down the probability that's 3 out of 9, or I can just put in the 3 because I just put in the number of elements in there as well. Divided by the probability of it being odd. Well, how many odd numbers are there? Well, there's 1, 2, 3, 4. So it's 3 out of 4. The probability of it being prime, given that it is odd, is 3 in 4. There's a 3 in 4 chance. Once we know it's odd, there's the 3 in 4 chance that it is prime. Okay. If it is odd, then there is a 3 in 4 chance that it is prime. Find the probability that it is odd, given that it's prime. Again, that's going to be the same thing on the top. Probability of it being odd and prime, which is the same as prime and odd. All divided by, but this time the condition is that it is a prime. So the probability of it being odd and prime, well, that's still 3 on the top. Now divided by the probability that it's a prime number. How many prime numbers are in here? Well, the prime number is 2, 3, 5, and 7. So there's a 3 in 4 chance there. So that's conditional probability. That's how that works. The next thing we look at is using this rule to derive an expression for the multiplication rule. So remember your rule: the probability of A given B is equal to the probability of A intersection B divided by the probability of B.